Hi, everybody. In this video, I want to talk about sets. And again, just a reminder, don't forget to add your dates in and any additional notes that you feel would be helpful at the end of the lecture. So sets, a set is a collection of objects whose contents can be clearly determined. Now we're going to focus on mathematical sets, of course, but if you think about sets, they exist in our regular world too, right? So you could have a set of baseball cards. Perhaps I own Red Sox cards from a particular year or something like that. So we have sets in math too, where it's a collection of items that usually have some sort of pattern or relationship to one another. And I think once I show you some examples, it'll make a little bit more sense and you'll say, oh, I've seen that before. Now, all of these objects within a set we call elements. Okay, there we go. So there are actually a couple of different ways that we can express sets as well. My cat's coming to visit. Sorry, guys. The joys of working from home, right? And one way to express them is called the roster method. Okay. So basically, you just list all the elements out. And we just use commas to separate those elements. So for example, I would use squiggly brackets. Those represent sets. So we don't use parentheses or square brackets, use those little squiggly brackets. And I'm going to use one example like this. So the set of numbers 1, 2, 3, 4, 5. Notice that it's a closed set. I don't have any dots anywhere. So this is a finite set. There are only 5 values here. If I wanted to extend that pattern, let's say I wanted to keep it going forever, I could use ... which shows that it also continues on. So you would follow the same pattern, whatever that is. So I would continue 6, 7, 8, 9, 10, etc. A couple other examples. So something similar, maybe I have something like even numbers starting at 2. Maybe I just want to do the first 3 even numbers for my set, or maybe I want to continue that pattern and I could write ... which shows that that pattern continues. So this is called the roster method. We see that a lot. It's very helpful if there are not too many elements in the set, or if it's easy to list as a pattern. So we can put that ... and it's very clear for the reader to know what that pattern is, right? We wouldn't want to use the ... method if there was no pattern between the numbers or if it was very difficult to figure out. And again, the key thing is though, these squiggly brackets are what you want to use for set. If you use parentheses or square brackets, it'll be marked wrong. So that's really important here. The second way we write things, and you've again probably seen it before, is called either set notation or more formally set builder notation. And in this case, we, instead of listing them out, we more like describe the elements. So for something like this first one here, there's actually a few different ways that you could write it. I could write something like X, such that X is a counting number less than 6. Or I could describe that same set and write X such that X is an integer, and let's see, we're going from 1 through 5. X is between 1 and 5. And I'm including 1 or 5, right? Because I have less than or equal to symbols there. So these are 2 different ways that I could express that same first set here. Okay. I can just zoom out a little bit so we can see it all. So we're usually more like describing the set. And the set builder notation works particularly well if our set is long or infinite or a bit difficult to list all the elements out for. So sometimes in this example, that roster notation is much easier, I think, and much clearer. But in other times, the set builder notation is actually easier to write with. Let me do another one. So for the next one, I could write something like X such that X is a counting number 1 or greater. So here, remember our set was infinite, right? The numbers kept going. So I want to write that as set builder notation. One way I could describe it is that X is a counting number 1 or greater, right? So I start at 1 and I count upward. Or I could say X is an integer 1 or greater. That also works. So there's different ways that you could describe your sets. You know, for this one, we could say something like X is an even integer between 2 and 6, right? So we would just describe it more in words, or sometimes using our inequality symbols is very common as well. One other thing I want to note is just this notation here. So this notation of X such that is read like that. So it's read X such that, and so on. So that line here really means such that when you see that in mathematics in a set notation like this. Notice we're still using those squiggly brackets to represent sets. So these are the two main ways that we have sets. We also sometimes will just write them in words and kind of almost describe them in paragraph form, but that tends to be less common. So typically for shorter sets, we like the roster notation, and for more complicated sets, we tend to use the set builder notation. We usually like to just pick one that is the easiest for the reader to understand. Now, once you have your sets, we do like to be able to do some work with them. So there's two main things that we tend to look at, and that would be intersections and unions. So the intersection of sets sorry about that, guys. The intersection of sets A and B, let's try this again. Written A intersect B. So when we have sets, we tend to name them with capital letters. You're going to see that comment. So we'll say, oh, this is called set A or set B, set C, it doesn't matter. But we tend to use capital letters to name our sets. Just makes them a little bit easier to talk about. So you see that notation. And this upside down U here represents the word intersection. So you see that there. And what it is the set of elements in common to both sets A and B. Okay, so for instance, let's say I had an example. So maybe set A is the set 1, 2, 3, 4, 5, and set B is that set 2, 4, and 6. Well, the intersection of these sets would be any elements that are in common to both. So if I look at these two sets, I can see that they both have a 2 and they both have a 4, and that's the only thing they have in common. So our intersection there is 2 and 4. Let's keep set A the same. And let's say set B this time is the set 5, 6, 7, 8, etc. Well, in this case, even though this continues on, I understand the pattern is getting higher. I don't see any overlap there. I only have one number that's in common, and that's okay. So the intersection of these sets is just 5. I still use those squiggly brackets around the 5 because I am using set notation here. Okay. if I have an example, let's go over here. Let's do another one. I'm just going to keep set A the same. Just kind of keep it consistent. So let's set A is the same and set B is almost the same, but it's all the negative numbers. So what happens is they have nothing in common. There's no intersection. There's no overlap at all. So when you think of intersection, you want to think of overlap. What's in common? Okay, so let's make a note of that. That word intersection. You want to think of what is overlapping or what is in common. There's nothing here. So when there's nothing there, what we do is we use a notation, and it is called the empty or null set. So it looks like this. It looks like a 0 with a line through it. And this is called the empty set, or we say the null set. So basically that means there is nothing. It's totally empty. There's nothing in common here. Okay. When using this notation, you do not need to put set symbols around it. That actually means something different. It's a little bit weird. That would mean the set of the null set. It's a little bit strange. So you don't need the set notation only when you're using the empty set in most cases. So for our purposes, that would be sufficient here. Okay. Now, if for some reason you had the same set written twice and everything was in common, that's okay too. You would just write that as your answer. So for intersection, we're just looking for anything in common. Now, the other definition I want to give is for union. Now, a union is actually the opposite. So instead of looking at the overlap, you're actually going to combine the two sets totally together. So the union of sets A and B, written as A union B. So notice that's a very similar notation, but the U is facing the regular direction. So kind of the way I remember it is it looks like a U for union, whereas the other one almost looks like an N for intersection. So that's how I remember the two symbols. This one almost looks like an N, so I think of intersection, whereas this one looks like a U, and I think of union. So the union is the set of elements that are members of set A or set B or of both sets. Okay. Oops, let's fix that. Okay. So basically what you're doing here when you think of union, you're sort of combining both sets together, but don't repeat your elements. So that actually is important. You don't want to repeat your elements. So for example, let's say we had A was 1, 2, and 3, and set B here was 2, 4, and 6. Then A union B is just going to be all that put together. So I have 1, 2, and 3 from A. And then for B, I don't have to repeat the 2 because I already have it. So I just attach in 4 and 6. So that would be our union. You don't actually have to put the elements in order, which is kind of nice, although most people do. It is pretty standard to put them in order, but you don't have to. So this is how we can write our union. Basically, just combine your two sets, but don't repeat. Now, in the next video, I'm going to talk more about sets, but really talk about specific math sets that we use all the time.